Hello everyone, welcome back to Garuda classes. For today's lecture, we are going to discuss about visibility and the fog. Okay, in simplest term, visibility can be defined as the furthest horizontal distance on the ground that you can see uh, a dark object against a bright background with your naked eyes. Okay? This is the standard definition of visibility. In simplest words, how far you can see an object. Okay, just by your eyes can be defined as visibility. Okay. In day, it is very easy to measure visibility. For example, you can look at a hill. Okay, you can look at a long distance temple. If you know the distance between temples, you know the distance between the hills. You can tell that if the hill is visible or the temple is visible, that means the visibility is 10 kilometer or so on. Okay, for example. But at night, it became little tricky to measure the light. So what we do, we generally rely on the light sources. Okay, there is one equipment called as gold visibility meter that is used to measure uh, uh, your distance visibility at night. So at night, the distance will be given as the light of 1000 candela. Candela is a unit of light. Okay, can be seen and identified against an unlit background, means a dark background. Okay, these are the standard definition of visibility. So we'll write it down. So you can see in this image as well what a bad visibility looks like. How is a good visibility? Okay, in good visibility condition, the runway is clearly visible. Right, in a bad visibility condition, you need to look at hazy. Okay, you cannot see the runway and the lights are not properly visible. And as in pilot, we require a good visibility. For flying in VFR, it is mandatory to have the visibility more than 5 kilometers. Okay, so write down the definition of visibility. Visibility is the furthest horizontal distance on the ground that you can see a dark object against a bright background with naked light. Okay. And at night, the greatest distance in which light of 1000 candela can be seen and identify against unlit background. Okay, so what else we got? This is the definition of visibility at night in that. Now we have something called as RVR, known as runway visual range. So the main visibility for nowadays, most of the airliners fly IFR, right? They rely on instrument flying. So the visibility is applicable for them only up to on runway, because at the landing time they need to be runway should be visual to them. Okay, so we have a concept of runway visual range. Now this runway visual range is reported whenever the visibility is less than 1500 meters. Okay, the visibility is generally referred to measured in meters. Okay, so for the VFR flying, it is compulsory to have visibility more than 5 kilometers, that is 5000 meters. And sometimes your IFR flying, where lower visibility also we can land. Okay. Now RVR is only reported. RVR is the visibility across the runway. We got different touchdown points. At different touchdown points, we generally see how much the visibility on the different segment. For example, touchdown zone. Okay, then midpoint and stop end. So that time we see how much the visibility on that runway is. Okay, so RVR refers to as runway visual range. Okay, and this is reported when visibility is less than 1500 meters. Okay, whenever there is a lesser visibility than 1500 meters, that time we used to give RVR. Okay, now how the RVR is given? Basically your RVR is given by a measuring equipment known as transitometer. Okay, I'll show you the figure of transitometer. Okay, this is transmisometer. Okay, this is used to measure the visibility across the runway. So what happened? It is placed around 87 meters from the runway, and approximately it's about 15 meter of height. Okay, this is used to give the distance from the visibility, whatever the visibility is across runway. And generally, there are 3 points where the RVR is measured. Okay, so this 3 point. So if you see the runway from the top end, this is known as touchdown point. Okay, this zone where your aircraft is supposed to touch down. Okay, then we got midpoint, the center of the runway, then a stop end. So generally, RVR is measured. It can be given across 3 points. Okay. So this is your touchdown point, midpoint, and stop point. Okay. So RVR is given something like if say RVR 36. Okay, and 200. So this means the runway visual range of runway 36. Okay, 36 is the magnetic orientation of your runway. Okay, now it will given that it is 1200 because the visibility is 200 meters less than 1500 meters. Okay, sometime if the you got different type of runway 36R, 36L. So two parallel runways are there. One is named as 36L and another name is 36R. Okay, 1200 meter, then 850, 900. So what that signifies, the first RVR is for your touch point. Okay, second is for your midpoint, and the last one is for your stop point. Okay, and sometimes generally what happens that instead of giving all the three, they just specifically mention that RVR 36R. Okay, for touchdown zone, because touchdown zone is the most important point. Then they might write just midpoint and 900. So this was the visibility. Okay. Whenever the RVR visibility is more than say 1500 meter, it is written as P1500. Okay. Similarly, if the trending visibility is increasing, so that time the prefix for visibility is U, and for decreasing visibility it is D. Okay, and no change is denoted by no N. Sorry, no change. Okay, so these are the RVR distances. So what are the causes of decreasing the visibility? Okay, the primary causes could be many things could be causing the visibility to drop. For example, smoke particles, okay, sea spray, dust, okay, moisture that have been condensed, okay, volcanic ash, pollution, etc. Okay, based on different pollutants or different causes and the visibility parameter, that is how much the visibility it is. We have different type of um, you can say different type of your conditions. Okay, for example, haze, mist. Okay, we'll see in detail. First, write down the causes. The causes for poor visibility. Okay, the first is smoke particles. Then you got sea sprays. Then you got dust. Then you got condensed moisture. Okay. Then you got volcanic ash. Okay, whenever they are nearby the volcano, active volcano, when it erupts, it release a lot of ash in the atmosphere, which reduce the visibility significantly. Pollution is one of them. Okay, smoke pollution that is being released by factories in the atmosphere. Okay, so first such type of condition we are going to look into is haze. Okay, haze. So what happened? The haze is basically whenever the visibility is less than 5,000 meters, and the reason could be smoke, dust, and water, etc. So we'll show you. Okay, haze, the visibility is less than 5,000 meter, smoke, dust, water, etc. For exam purpose, just keep in mind that you have to remember the visibility range, because they will give you what is the visibility condition in haze and what are the causes. Causes are rarely been asked, but the visibility parameter, how much is the range, you must remember. Now, one example of haze, we got dust haze. Okay, subtype you can call it. A subtype is your dust haze. Okay, your dust haze is obviously because of the dust. Okay, now dust haze, the characteristic is something like that. It's been strong during the day, and as the night progress, this got weakens. Okay, and the range it extends is from 6 to 8 kilometer vertically. So write it down, and something like this mostly across your arid region, yeah, desert region where there's a lot of sand and when there is a lot of hotness is present. That time your dust is being can be visual. Okay, the dust blown from by storm during day, would weaken by night. Okay, and it extended up to 6 to 8 kilometer vertically. Vertically. Okay. Now this desert semi-arid area along with around Rajasthan, Haryana, UP, etc. during the summer season. You can find that this desert regions. Okay. Uh, Next type of haze we are looking into is your smoke haze. That is because of your presence of the smoke. Okay. So this is haze, dust haze, and now smoke haze because of calm and strong ground inversion and presence of smoke pollution along city. So this type of haze you mostly see around metro cities like Delhi and Mumbai because there is a lot of pollution being present over there. And this act like a agent. Okay, we'll discuss about that in short time. And talking about mist, mist in this visibility drops from 1000 meter to 5000 meter, and the relative humidity is almost 100. So what happens when there is a relative humidity 100%? The condensation of moisture present in the atmosphere will result into decreasing visibility. Okay. Now talking about fog, fog and mist are almost similar to each other. Just the visibility parameter is different. Okay. If the visibility is from 1000 to 5000 meters, that time we call it as mist, and then it falls below that, we call it as fog. Okay. And the fog can also be called as stratus cloud sitting on the ground. Okay. Because there is suspension of water droplets or ice particles in the atmosphere. Okay. So if you enter in a fog area or you enter in a stratus cloud, you will see similar view. So this is about fog and mist. The next point is your smog. Okay. Smog is something called as fog plus smoke. Okay. Or hazes also can coexist. What happened in the smog? Your dust particle, okay, or the smoke particles will act as hygroscopic nuclei, and the moisture around that will condense and create a form, larger molecule. This molecule will hinder your visibility. So fog plus smoke or haze coexist. So smog equal to smoke plus fog. This also been asked a lot of time in BGC. So be careful on that. This your smoke particles will act as the hygroscopic nuclei. Hygroscopic means it will attract water molecule towards it. Hygroscopic nuclei. Okay. And the water droplet will try to stick to that. Okay. When sticking, it create a larger molecule which will hinder your visibility. Okay. The next point is your dust storm. Okay. What is dust storm? Dust storm basically you can find in the arid region, and this is present along region of like Dubai, Middle East, and Sahara Desert. Along that, there is a lot type of your dust storms coming. Okay, and they have different name in local area. So you can see this is the images of dust storm in different region. It is called as such as Habub in Middle East, Sahara Desert side, and in India it's called as Kal Baisakhi or Andhi. Okay, in which there are a lot of dust being grown, and definitely you can see in this the visibility is drastically reduced. Okay, and the visibility parameter is generally less than 5000 meters. Okay, next is your sea spray. What happened in your sea spray? Okay, your sea spray in which you can find along a coastal region. Your salt particle that is coming from the sea will act as a hygroscopic nuclei. Again, the same thing will happen. The condensation of water particle around the salt will result in the formation of a larger molecule which reduce your visibility. Okay, so your salt particles released in atmosphere which result to condensation of water particle. water particles. These are resulting in reduced visibility. Okay, the next point is your volcanic ash. Okay, and volcanic ash, what happened again? There is volcanic eruption, and there's a lot of ashes been released, and this ash will drastically reduce your visibility. Okay, I won't be showing you image for that. Volcanic ash, OVA. Okay. The next point is your precipitation, and obviously whenever it is raining, okay, the visibility is drastically reduced, and it will depend on how much rain it is there. If the rain is heavy, that time the visibility is lower than 1000 meters, and for heavy rain it's less than 1000 meter, and moderate to heavy rain 500 1000 meters. I'll show you just a second. Precipitation. Okay, so in this image you can see for the heavy rain, the visibility is typically around 1000 meter to, or like in moderate rain it is between 3000 meter and 10 kilometer, and moderate to heavy drizzle between 500 to 300 meter. And few more points to remember is that whenever you are looking towards the sun, the visibility drops. So it's a very important point to remember that visibility is lower looking toward the sun. Okay, and better when looking into the moon. Whenever you're looking directly in the sun, you cannot see, but you can look at the moon. So remember that. You cannot look into the sun, so visibility is dropped, but you can look at the moon, so visibility is better. Okay, and there is one more thing as oblique visibility and slant visibility. Remember that whenever if you are approaching a runway, okay, that time it might don't have uh, whenever you are at the top of a runway, okay, you see for example you're like this, okay, you can see the visibility is better. Okay, but when you come for landing like this, that time the slant range is working in a place. Okay, this distance might be less than this distance. Okay. For example, the visibility range is like this. Okay, from up top it is visual, but at the slant distance, the visibility is not that good. Okay, so remember that vertical visibility may be good, but slant visibility may be poor. Okay, we'll discuss about the next topic. That are the types of the fog. Okay, the first type of fog we are going to study is about the radiation fog. Okay, the first type is your radiation fog. Okay, so radiation fog is due whenever at night there is loss of your surface temperature dramatically, because if you remember that soil will lose heat very rapidly and gain heat very rapidly. That will, because of that, your surface temperature loses the temperature very quickly and allow the condensation to be formed. Okay, so this type of radiation fogs are generally at the lower level itself, few hundred meter to 1500 meters of the height, and This one of the reasons for that is your nocturnal cooling of the surface. Okay, adjacent layer of the air is also getting cool due to your the okay adjacent layer is getting colder and colder and creating the fog. So it is up to few hundred to 1500 feet of height. Your radiation fog form due to the nocturnal cooling of the surface. Okay, and the adjacent layer of air. Okay, this is because of radiation form. This will create a radiation form. Now, what are the conditions in this that your temperature is less than the dew point and the humidity is higher. You got higher humidity. Okay, so I'll write it down the condition very clearly. The first condition is that your high relative humidity. Okay, then you got clear sky, light wind. Okay, light wind is approximately 3 to 7 knots wind. Then you got stable atmosphere. Okay. Stable atmosphere will act as a lid. Okay, if it is turbulent weather or that will create a maximum of atmosphere, won't let this radiation fog to be formed. Okay, the stable atmosphere, light wind won't allow the mixing of air properly. The sky is clear, so no the cloudy sky we have seen that your radiation is reflected back, heat is trapped, it is warmer in the um, cloudy night, so clear sky is required, then high relative humidity, and whenever the surface temperature that drastically started to dropping down, and so what will happen, you will remember the specific heat of your soil is point to somewhere, so this will allow this temperature to drop quickly at around ground, and the adjacent layer will, due to conduction also decreases temperature, resulting into layer of formation of radiation. Okay, and this type of fog is more common in around sunrise and dissipate around after 2 3 hours. Okay, and also form around your high or cool region, because cold region has a very calm wind, so that allow the formation of radiation. It is most common around sunrise and dissipates after 2 3 hours. Okay, and you can find it around high or cold region. Okay, next type of fog is your advection fog. Okay, one more point to remember in the radiation fog. It is also formed in the valley region, um, because there is a sufficient presence of water moisture whenever the river is present. Okay, and temperature is stable enough, so can give you the creation of your radiation fog and the value region also. Okay. Talking about the advection fogs occur mostly around sea area. What happened? Say example, your warm air mass. Take you got a warm sea over one region, and let's get too dark, and a cold sea around other region, like this. Okay. So what happened? The moisture or vapors around this region, when travels to warm moisture, travel to your colder region. So what happened? This will condense over here because of the temperature differences. Okay, because this is a warm moisture and it comes to a colder region, rapidly condenses, giving you the advection fog. Okay, so let's write it down for points. The warm moisture is transported to the cold surface. This type of fog can also be created on land as well. Whenever the moisture is traveling from sea to the land, that also can create the advection fog. So advection fog forms both on land and sea. Okay. The next type of fog is on steaming fog. And this fog is also called as sea smoke. Why it's called sea smoke? We'll see. Okay. Now take a warmer sea. Okay, this is a warmer sea. What happen? A warm air mass, moist air mass is present over there. Now this warm air mass, whenever there is a cold weather is blown on that, okay, this cold weather will condense. Okay, earlier it was warm, then it became cold. Okay, so what will happen? This time this will be converted into a steaming fog. Okay, so in earlier cases, your this warm air mass was moving. In this case, in steaming fog, generally a cold air is blowing over that region, uh, resulting into condensation. Okay, so at higher latitudes, cold air mass flows over warm sea, creating steaming fog. Okay, this is also called as sea smoke. Okay. The next type of fog is the frontal fog, and this is because whenever there is a front, warm front is moving forward, there are clouds being present. So this cloud will give a rain. This rain will create a lot of moisture. Okay, this moisture, when moving into cold front, will condense and creating a frontal fog. Okay, you can see. Okay, this is a warm front. This is cold air mass. Okay, this is moving toward this one. Now creating a lot of clouds like nimbo stratus, also stratus. Okay, this type of cloud in there and will result into heavy rain. This rain will give moisture. This moisture will condense and result in your frontal fog. Okay, this is approximately 200 nautical mile. Okay. Now, what are the method for fog dispersal? So, how we can reduce your fog? So, there are only two methods. First is your thermal method. Increase the temperature. This will reduce your fog. Or second temperature is by hygroscopic nuclei. So, if you remember in the earlier chapter, we have discussed like spraying of artificial agents like common salt, NaCl, okay, sodium iodide, that time of things when we spray around the fog will act as a nuclei and attract all the moisture and will drop as rain and reduce the fog. Okay, so write down the fog dispersal methods. First is your thermal method. Second is your use of hygroscopic nuclei. Okay.